Okay, here we've got the last question on the paper. Tricky topic, but loads of show that's and loads of re-entry points. So tackle it in stages and don't panic. We've got a curve and a line, and in part A, it's a show that question. This thing here is the end point. Don't even look at it until you found the start point and worked with it. Okay? Forget all about that. The start point is points of intersection. Okay? And points of intersection is code for find some simultaneous equations for the line and the curve. There's the curve, there's the line. Substitute one into the other, and then without cheating in your algebra, rearrange until you get down to this, and you get 1 mark. And even if you couldn't get that mark, that's your starting point for the next bit, so here's a lovely friendly re-entry point. Okay. Now we've got the curve and the line intersecting 2 distinct points. This is the equation that applies to points of intersection, so this is our starting point. We need to show there are 2 distinct points, so this equation must have 2 distinct roots. What tells you about how many roots it's got? Okay, well that's your starting point. 2 distinct points means that it's going to be that thing with b squareds in it from chapter 1, a discriminant. Okay, you always compare it with naught. There's either an equal sign here or an inequality sign here. Do not look at what this is. Show that. So this is your end point again. Cover it up, forget all about it until you set up the discriminant being either something in relation to naught, and set that up from the word go. Put the naught in with the inequality or equal sign, whatever you need, and decide what your a, b and your c are next. Well, from your equation, that's going to be your x squared term, so your a will be something, and then your b will be something from that term, and then your c will be something from here. Lob them into that, make the correct comparison with naught, and at the very end of your working it will simplify to this. Okay, don't get mesmerised by this before too early. Alright, and then biggest re-entry point of all, even if you couldn't do any of that, we've just got to solve this. In fact, it doesn't even expect you to pick up that's what you have to do. It just says solve the inequality that you've just done. So solving a quadratic inequality, you do with a graph, you decide which way up it is, you find the critical values where the graph crosses the x-axis, factorise carefully, get 2 values where it crosses the x-axis, and then use your graph to decide whether you're between those values or outside them. State your solution clearly, and the last 4 marks are much easier than the first 4 for most people.